Okay, now that we've done the introduction problem, which was a two proportion analysis, now we're going to do a comparison of two means. And just like for the single mean, the difference between a z and a t is the standard deviation. When the population standard deviations are known, and remember those, that's the symbol. But there's going to be two of them now because there's two groups. You would use the z. If we don't know population standard deviation and we have to rely on the sample standard deviations, then we're going to have to use the t. Okay, now chapter 24 begins in the book with this guy. He's just sitting back. He's probably in between classes at college, and he's listening to his Walkman. Notice the cords. He doesn't have AirPods because this was like back in 2002. Now, what we're doing is we are going to compare batteries that we get at Walmart, okay, with Walmart brand batteries and Duracell batteries to see, does one of them last longer? Now, in function notation, y equals f of x. Y equals f of x. Okay. If we were to build an experiment, the response variable is number of minutes. Okay. How long will the batteries run the Walkman? Okay. Now, there is only one factor in this problem, and that's what the x is. Okay, so the battery type. Okay. Now, there are two levels to this factor. Okay, the Walmart and the Duracell. Okay, typically I do this, except I wrote here. There's one factor, or sorry, there's one factor, and there are two levels. The Walmart and the Duracell. Okay. But whatever the x is in y equals f of x, that is the factor. Okay. A common mistake would be people saying there are two factors in this experiment. Okay. There aren't. There's only one factor, the battery. Okay. There are two levels to that factor. Now, notice these are summary statistics. Okay. How many trials? N equals 11. They did 11 trials with the Walmart batteries. They did 15 trials with the Duracell batteries. Okay. Here's the mean and the sample standard deviation. Okay. Notice that's important because it's the S. And then here's the 5-number summary. We haven't talked about the 5-number summary in a long time, but it's going to come into play. As with any analysis, we begin with drawing a picture. Back in the early chapters, the picture we drew when comparing the results of data analysis, one of the pictures we drew was a comparison box plot. And that's what we're going to do here too. Now, we're not going to test for outliers. I can tell you right now, well, we don't know anyway because we didn't have the raw data. Okay, but there were no outliers. So let's make the Walmart box and whisker plot first. Okay, the low was 169.5. 169 would be almost 170, which would be a who knows about right here. Okay. The first quartile, 172.4. Okay, probably about somewhere about right here. Let's see, the median 189, so almost at 190, which would be in the middle of here. So let's call that right here. Let's see, the third quartile, 199.2. So almost 200, which would be about right here in the middle of here. Okay. So let's see if I can make a decent box out of this. Okay, and then the upper whisker, the high is 205.5, just a tiny, well, basically call it 205 right there. And so there's your box and whisker plot for the Walmart trials. Now the Duracell trials. The low was 190.7. Okay, 85, 95, 90, 190.7. Who knows? It'd be somewhere about right here. Let's see. The first quartile, 203.5, almost over here to 205. I don't want it that high. And I'll bring it a little bit lower. The median, right at 205. Okay. The third quartile at 209.4, so basically at 210. Okay, so here's the box. The long whisker down here to the low, and the high was 222.5. So almost up here, almost up to 225. Okay, and there we go. There's the comparison box and whisker plots of the two different types of batteries. Now, this picture tells us a lot. I mean, we kind of know where we're going here. It seems like the Duracell batteries are outperforming the Walmart batteries, but are they doing it significantly? That's what everything is all about. That's what the hypothesis test is going to be about, and that's what the confidence interval is going to be about. The confidence interval is going to be about what is the true difference between the performances. The hypothesis test is Duracell really outperforming Walmart? Okay. Now, we do have conditions that we always have to meet. Okay, you already know them. The independence condition, the randomization condition. Okay, the normal enough. Usually, so far we've looked at histograms, but we didn't have the raw data to make the histogram. So what we're going to look at is the box and whisker plot. Now the box and whisker plot doesn't tell us the height, so we can't see a bell shape, but we can see approximate symmetry. Okay. These aren't perfect. Remember, they never are. Okay. But, is the middle somewhere near, is the median somewhere near the middle of the box? Yes, on both of them. And is the symmetry, is the variation on both sides somewhat similar? Yes. So what we say is we don't reference a histogram because we don't have a histogram, but we do say that the box and whisker plots are both somewhat symmetric. Degrees of freedom. If it's a t-test, I'm gonna need degrees of freedom. Okay. So degrees of freedom are going to be n minus 1 of the smaller n. Okay. Now, the Walmart batteries had 11 trials. N equals 11 and 15. The Duracell side of the experiment had 15 trials. So we're going to take n minus 1 of the smaller n. So 11 minus 1 is 10. That's going to be the degrees of freedom in the problem. Now, your calculator is going to ask you something about, do you want to pool the results? You're always going to say no. And remember, we're analyzing the differences between the two averages, not just the averages themselves. Okay, let's do the hypothesis test to see if the Duracell batteries really do last longer. Okay. Now, if you go back to the data, flip back. Remember we talked about the only standard deviation we know in the problem is the sample standard deviation, which means it's going to be a 2-sample t-test. Okay, that's going to be the name of the test, 2-sample t-test. And the null hypothesis is simply going to be that the two batteries are equal. Now, the Walmart batteries were the ones that were listed first in the data. So I'm going to do what I almost always do. I'm just going to put Walmart on the left because they were referenced first. Mu of Walmart equals mu of Duracell. And then the alternative hypothesis is going to be what we're actually trying to show. Are Duracell batteries really greater than Walmart batteries? Okay. Now, I need to reference what W and D are, even though it's incredibly obvious in the problem. W means Walmart. D equals Duracell. Okay, so there's step one. Write the HO and HA. We're going to let the calculator do everything, just like we did on 2-prop analysis. The formulas are ugly, so we're just going to go straight to the p-value, but we got to get it. Okay. So, on your calculator, stat, test, okay, 2-sample t-test. That's what we're going after right now, the 2-sample t-test. Now it's going to ask everything we know, okay? It's going to ask what was the mean of group number 1. Group number 1 is whatever you put on the left-hand side of the hypothesis test. Okay? And I put Walmart. So I'm going to put the Walmart's mean, which is 187.43. The next thing it asks is what was the standard deviation, 14.61. Okay. The next thing it asks is, well, how many? What was the sample size of group 1? And it was 11. Now it's going to ask everything about group 2. What was the mean of the Duracell batteries? 206.01. What was the standard deviation? 10.30. What was the sample size? 15. Okay. And let's see, this was actually it was a one-tail low test because I had Walmart on the left-hand side. Okay. So I had the less than sign going in the HA. So it's a one-tail low test. Okay. Here's where the calculator is just saying, do you want to pool the samples? And the answer is no. Say no. Okay. And then just go down to calculate. Okay. And the calculator is going to tell you two things. The p-value is 0.001. So we can do that. The p-value 0.001. And it's also going to tell you the t. That would be the t-star, the test statistic. And it's negative 3.61. Okay. Now, if we wanted to, we could draw and label the curve. Okay, it's a one-tail low test. Remember, the degrees of freedom were n minus 1 of the smaller n. So degrees of freedom would be 11 minus 1, which is 10. So what would be the critical point? Okay. One-tail probability. One-tail probability. Alpha equals 0.05. Okay. So go straight down until you get 10 degrees of freedom, and you get negative 1.812 because we're on the low side. Okay, so either way you look at it, okay, the T star is negative 3.61, so it's way over here because 0 is in the middle. So we surpass negative 1.812 when we get into the rejection area, or you look at it from the p-value standpoint, okay, since 0.001 is less than 0.05, we would reject HO. So any way you do it, let's write at 95% confidence. There is evidence to reject HO. It appears that Duracell batteries do last significantly longer than Walmart. And there's the hypothesis test. Let's follow up with a 90% confidence interval. And the reason I switched to 90%, we did the hypothesis test at 95, but it was a one-tail. So confidence intervals are always two-tailed. So just to keep everything consistent, I'm going to do a 90% confidence interval for the true difference. Well, the interval we'd be doing is a 2-sample T interval. Okay. You're going to find that in your calculator, obviously. Stat test 2-sample T int. There it is right there. Option 0 for me. Okay. Now, since I've already put everything in, since I just did the hypothesis test, everything came through. So everything's still there. I am going to change it to 90% from 95. Okay. I'm still going to say no to when it asks, do I want to pool the information? Okay. All right, now I'm going to go down to calculate. Now remember one thing, confidence intervals are always built from the perspective of whatever group was on the left or whoever group 1 was. Well, in our situation, group 1 was Walmart batteries. So this interval is from the perspective of Walmart batteries. Now on the lower, I've got negative 27.53. That's the lower end of the interval. The upper end of the interval is negative 9.629. Okay, and that's the interval. Okay. So we could say, with 90% confidence, Walmart batteries last anywhere from 27.53 minutes to 9.629 minutes. And since they're negative, it's less when compared to Duracell. Now, the presence of 0 in the interval means something, and the lack of a presence of 0 means something. Okay? So 0 does not appear in this interval. Both sides are negative. Since 0 is not in the interval, Walmart is significantly less. Okay. If you get an interval where 0 is in the interval, okay, there's a possibility that there's absolutely no difference at all. So that's the conclusion you would have to make. Okay, is there doesn't appear to be a significant difference, but there did in this one because both sides were negative. Okay, let's do another example, and we'll just do it really quickly. You can see how fast these things go when you're using your calculator to do everything. So we're at Hillview High School. The choir and the band are doing fundraisers. The band, the number of students who participated were 11, choir 9. Okay, the average amount raised for the band members, average amount raised for the choir, standard deviation. Okay, and this is the S. This is the X bar. Okay. Does it appear that the choir is raising more than the band? Okay. Well, test at 95% confidence. So let's go straight to it. The HO. Okay. The null hypothesis would simply be they are equal. The HA would be what we're trying to see. Is the choir outraising the band? So it'd be like that. Okay, and we'd have to define B equals band, C equals choir. Okay, so that'd be step 1. Step 2, p-value. Okay. So it's a 2-sample t-test. Okay. Stat, test, 2-sample t-test. There we go. Okay. Group 1, mean 332.47. Group 1, standard deviation 4140. Group 2, N 11. Group 2, mean 378.15. Standard deviation 5280. Group 2 sample size 9. Again, it's a one-tail low test because I put band on the left-hand side. Just say no when it says, do you want to pool the information? And then go to calculate. Okay, we're going to get a p-value of 0.026. Just in case you need it, you might want to write down the t-star. The test statistic is negative 2.12. Okay. But we are going to make the conclusion off of the p-value. We're not even going to draw and label the curve. Okay. Since 0.026 is less than 0.05, We're going to reject HO. Okay. It appears the choir is, let's see, raising more than the band. Okay. Now a 90% confidence interval. Stat test to sample T int. Okay. Everything flows through because we already put it in there. And pooled no, it is 90%. We are changing it to 90%. Okay. And we're going to get negative 83.5 on the low side. And on the high side, we're getting negative 7.859. That's our confidence interval. So we pretty much have the same result, or a similar result, as we had before. Use at 90% confidence. It appears the band is under, I guess, raising, performing, I don't know, under raising by $83.50 to $7.859, okay, versus the choir. Before we finish this problem altogether, let's go back to the hypothesis test for a second. You know, we let our calculator tell us the p-value was 0.026. We also let our calculator tell us that the test statistic T star was negative 2.12. But if we were to find a critical point, remember, again, this was a one-tail low test. Look at the HA, because I put the band on the left-hand side. If I'd have put choir on the left-hand side, it would have been a one-tail high test. But it's a one-tail low test. Okay. Degrees of freedom are n minus 1 of the smaller n. So the degrees of freedom would be 9 minus 1, which is 8. So one-tail probability at 0.05 with 8 degrees of freedom is 1.860, but it's on the low side, so it's negative 1.860. And you can see right here, the calculator told us the T star, the test statistic, was negative 2.12. So the test statistic tells us to reject HO. The p-value tells us to reject HO. So everything is working together.